Okay, ladies and gentlemen, we're going to look at a few examples of the derivative of inverse trig functions this morning. So I'm going to start with example 1 and illustrate how we actually use these formulas here. So here's an inverse trig function. You know it's an inverse trig function because of that -1 sign. That's not reciprocal, but that's inverse. And remember, you have a derivative formula here that y prime would be, go back to the chain rule version, 1 over the square root of 1 minus u squared du dx. So in this case here, we see here that u is going to be pi x. So this is the u portion here. So what I would do here is to say, okay, y prime, that derivative, 1 over the square root of 1 minus pi x in parentheses this to the second power, and by the chain portion multiplied by the derivative of pi x. And ladies and gentlemen, this is just going to be pi. So here's a very simple illustration of chain rule. We say y prime now will be pi over the square root of 1 minus pi squared x squared. So this is how we use chain rule with the derivative formula for inverse sine. And that's how we look at that, but don't forget, you always have the chain portion here. That's chain rule. Okay. Now, sometimes they give you the notation in function notation. So if they gave us, for example, inverse cosine of maybe 2 pi x here. The derivative formula here, the chain rule version, in terms of operator notation, we say we're going to take the derivative of the inverse cosine 2 pi x times the derivative of that inside function. Remember, this is composition of functions here. So this is that u they're talking about here. And it's placed here too. So here's the u. Now, what this means is we have minus 1 over square root 1 minus 2 pi x squared. And then that's times 2 pi. So let's put this chain portion here. Okay, because what we are using, the formula we talked about in class, that if you differentiate the inverse cosine of u, that's minus 1 over square root 1 minus u squared du dx. So, ladies and gentlemen, this is here an example of what you are using. So I guess we'll put that in a box. And it's an example of what we just used up here. But notice again, we have to finish the algebra. So you can call this f prime x, and that will equal minus 2 pi over square root 1 minus 4 pi squared x squared. Because you want to square that 2 pi x. So here you go, ladies and gentlemen. This is an example of, and let's actually number this 3 in case there's a future worksheet I create for this. So we'll number that 3. Or who knows? Yeah, we'll number them odd just in case there's a future worksheet written. But these are derivatives of trig functions, just starting out from scratch. And the next slide, number 5, we can put y equals maybe the inverse tangent of x over 4 here. A very similar kind of question. So you're going to use the chain rule version of this, 1 over u squared du dx, right? Or the operator notation for the derivative, f prime x being the derivative of inverse tangent u du dx. Okay, now remember that inside function, since this is composition of functions, here's my u. And so this derivative becomes 1 over 1 plus x over 4 squared, the derivative of x over 4. This is chain rule. So don't forget the derivative of x over 4 here from the chain portion is 1/4. So, okay, we have that value. And now y prime becomes 1 over that 4 times 1 plus x squared over 16. So we get 1 over, now distribute that 4. Right, we're going to algebraically simplify this. Distribute your 4, so you'll get 4 plus x squared over 4. Now, you might look at this and say, is that an appropriate answer? And I'll say, no, what you want to do now is actually, we're going to do a little bit of algebra here. This really means you have, let's simplify the denominator. Let's add 4, to x squared over 4, meaning we're going to multiply 4, divide by 4. So you'll have 1 over 16 over 4 plus x squared over 4, and that gives you 1 over 16 plus x squared over 4. Now remember, 1 divided by 16 plus x squared over 4 is the same as 1 times 4 over 16 plus x squared, which gives you 4 over 16x squared. So we're going to do the algebra here so we get a nice rational function. And this is actually another good approach to what you're doing here. So we had some algebra in this one. And it looks like you'll have algebra when you have that argument being a fraction. So you're going to use the definition of what it means to divide. It's a complex fraction in that way. So here's your derivative. Okay, let's try some more here. Let's say number 7, y is the inverse sine of maybe 3x plus 5. Again, you're going to use your derivative formula. That y prime will be 1 over square root 1 minus u squared du dx, where u again is right up in here. Let's maybe be consistent with our colors. Who knows? Let's use red. Here's that u. So the derivative will be 1 over square root 1 minus 3x plus 5 squared now times the derivative of 3x plus 5. And that's going to be 3. So we get 3 over the square root of 1 minus 3x plus 5 squared. Now we can, we can leave it like this, or we can expand that. But I think we'll leave it like this morning, since we're just trying to enjoy some derivatives with our coffee here. Number 7. But, you could use FOIL, I guess, if you wanted. Inverse cosine e to the x. So at this point, derivative formula for y prime would be 1 over square root 1 minus u squared, and I think that's a minus, and you have du dx. Where again, u is right in here, that inside function here. So maybe we should change that to red and it stands out. Remember, this is part of that chain portion you're going to use here. So that derivative will be negative 1 over the square root of 1 minus e to the x squared times the derivative of e to the x. So we know this derivative, that's e to the x. So our first derivative is minus e to the x over square root 1 minus e to the 2x. Because you have a base raised to a power raised to another power, you multiply the powers and you keep the base. So ladies and gentlemen, here is the derivative here. Kicking it up. Y equals inverse tangent. We're going to say natural log of x squared. So the derivative formula, 1 over 1 plus u squared du dx here, the chain portion. This is the u. So we'll get y prime going to be 1 over 1 plus natural log x squared squared, and u here is going to be natural log of x squared here. So this is the chain portion. So when we differentiate here, derivative of natural log of x squared is 1 over x squared times the derivative of x squared. Don't forget, there's the chain portion for this derivative as well, for natural log. And I wrote down the wrong notation, so. To x. So altogether, let's put that in green. You get 2x over x squared, and that gives you 2 over x. So, ladies and gentlemen, y prime is 1 over 1 plus, I'm going to put that square between, we're handling this power 2 here, and that goes right in here. So it's between natural log and the parentheses of x squared. That's how we can write the same sort of thing. And then by the chain portion, that's 2 times x here. So that y prime becomes 2 over, we'll say x 1 plus natural log squared of x squared. And we can put that in a bracket, I guess. And we don't necessarily have to use a distributive property here. But there you go. Here's that derivative. So, as we are proceeding here, you guys can see we're kicking it up. Give you an example here. Maybe y equals, let's say, x squared inverse sine of x. So you have two functions here. You have x squared. You have inverse sine x. So you're going to use here the product rule. So the product rule, you write every detail. You pull out the first function, x squared, and you differentiate the second function. Plus you pull out the second function, and you differentiate the first function. So if you wanted to see the colors here, x squared, here's x squared. This is your product rule. We just now have to go through the formulas here for derivatives. Now, this is inverse sine, so this is 1 over square root 1 minus u squared. And this is going to be simply 2x. So this derivative, y prime will be, and I guess we did the u version. We don't have to because there is no inside function there. So we have this x squared over square root 1 minus x squared plus 2x inverse sine x. And so we can leave our answer this way, or we can choose to add the fraction with the irrational, meaning we have to have the same denominator. So your answer will be here x squared plus 2x inverse sine x, and everything will be under that square root 1 minus x squared. And don't forget, there's a product here of a 1 minus x squared. Okay. So either would be an appropriate answer. I think, again, this morning we're just going to go through some of these here. But don't be surprised if later on, when you start to apply these derivatives, they use this answer here. They actually added the fraction with the whole term. So kicking this up, so let's say 15 now. I think we did something like this already, but how about we change this up? Y equals e to the inverse cosine x. So in this case, again, here, we have to know two things. The derivative formula for an exponential function. So remember, if I differentiate e to the u, that's e to the u du dx. So then we get y prime going to be that derivative of e inverse cosine x, which is e inverse cosine x d dx inverse cosine x. negative 1 over the square root 1 minus x squared. So this is the chain portion for this function here. And we end up with negative e. Let's move this down. Here's your derivative. And there it is. Okay, let's see. Let's make sure this marker still works. 17. How about y equals how about natural log of inverse tangent? So you need to know the derivative of the natural log function. Y prime is 1 over that inverse tangent of x. Now you can differentiate inverse tangent. So the derivative of inverse tangent is the square 1 over the square no square root 1 plus x squared. This is the derivative here using chain rule. So your y prime becomes 1 over 1 plus x squared inverse tangent. Okay, let's kick this up a bit. Let's see if we could kick it up. Y equals the inverse sine of x over x plus 1. And so y prime, remember, since you have a function here, we're going to call this function u. The derivative of the inverse sine, 1 over square root 1 minus u squared du dx by chain rule. So in this case, that's going to be 1 over square root 1 minus x over x plus 1 squared, and the derivative of x over x plus 1. So over on the right side, you're going to have to differentiate. You're going to use quotient rule. So let's find the red marker and say quotient rule. Okay. So I'm going to note here by quotient rule, when we take that derivative, we have the denominator to the second power, bring the denominator up here, differentiate x minus x differentiate x plus 1. Numerator function, denominator. So you take that denominator to the second power, it's back up here. Differentiate the numerator, bring out the numerator as a constant, and differentiate the denominator. So that's chain rule. That's the chain rule portion, or quotient rule. Sorry. QR for quotient rule. So this derivative here is 1, and this derivative is 1. So you get x plus 1 times 1 minus x times 1, everything over x plus 1 squared. So I get x plus 1 minus x over x plus 1 squared, which is 1 over x plus 1 squared. So this is the chain rule portion here that involve quotient rule. So that's 1 over x plus 1 squared. So we're going to replace that up here. And okay, we're going to have to see what this is all together. So we're going to have now y prime equal to, let's get out this denominator, this fraction here, 1 over square root 1 minus, okay, and then we get 1 over, so this is going to be, let's put it all together here so you guys can see this, times 1 over x plus 1 squared. Now, we're going to have to simplify this denominator down here. So let me just kind of emphasize that portion here. So you have to simplify this denominator. And what happens there, under the radical, all right, let's focus on this expression here. We have 1 minus, that'll be x squared over x plus 1 squared. And I'm going to replace this with x plus 1 squared over x plus 1 squared. So we can actually combine those terms. I'm focusing on that denominator, which gives us x plus 1 squared minus x squared over x plus 1 squared. So that's the gray portion here. And now that derivative is 1 over the square root of x plus 1 squared minus x squared over x plus 1 squared. And don't forget, that's times now a factor of x plus 1 squared. So what's going to happen here is properties of, see if you can see this here, x plus 1 squared in parentheses here. Let me do a couple things at once. So this we're going to expand, and you're going to see that there's going to be cancellation here. So if we expand that numerator, I guess I have to do every detail. I'll keep it like this for now. So that'll be x squared plus 2x plus 1 minus x squared over x plus 1 squared now. And don't forget that there's a factor of x plus 1 squared here. Now, what I started to say, this denominator here, everything that's right in here now, if we look at this portion here, 1 over, I'm going to use quotient rule. This will just be 2x plus 1. And by quotient rule, that's the square root of x plus 1 squared. And then I have that factor of x plus 1 squared. Now, the square root of x plus 1 squared, we get 1 over 2x plus 1 over simply x plus 1 times x plus 1 squared. And so we will cancel here. And what you are left with, 1 over the square root 2x plus 1 times x plus 1. And there you are, ladies and gentlemen. So as you can see, there's some algebra that we have to do here. But, you know, this is an example where we have quotient rule as well. And let's see, I forgot what number this is. This is maybe number, what, 19? Okay. 21. Y is inverse tangent of natural log. I think we did something very similar to that one already. How about if we change that to y is x minus inverse tangent of x? So that the derivative now will be x minus inverse tangent of x, the derivative of the quotient. One over 1 plus x squared. So y prime is 1 minus 1 over 1 plus x squared. So we're going to just simply here subtract a whole number from a fraction. And what I mean by that is we're going to, multiply by 1 plus x squared on the top and the bottom. And there you go. So interesting question. Maybe we should try another one that's going to involve quotient rule. Okay, we'll try another quotient rule question. Y is inverse tangent x minus 1, x plus 1. Okay. Y prime will be 1 over 1 plus x minus 1, x plus 1 squared. And we differentiate with x minus 1 over x plus 1. So over here, quotient rule. And as you can see, well, maybe we're going to do it like we just did. Let's do the quotient rule question now. So let's work on that quotient rule. So by quotient rule, x plus 1 squared, x plus 1. Remember, this is what we're going to go through. Here's my numerator. Here's my denominator. So we take that denominator and square it, bring up the denominator. Now take the derivative of the numerator, which is x minus 1. And quotient rule, this is minus the numerator times the derivative of the denominator. And there we go. So let's take these derivatives here. So this is going to be 1, and this is 1. And you're going to get now x plus 1 times 1 minus x minus 1 over 1 times 1. This is now x plus 1 squared. So the numerator becomes x plus 1 minus an x plus 1 when you distribute over x plus 1 squared. And so my x's cancel, and I have 2 over x plus 1 squared. 2 over x plus 1 squared. There we go. So let's put everything together here. Y prime is 1 over 1 plus x minus 1, x plus 1 squared. There we go. And that'll be times 2 over x plus 1 squared. And I'm going to put a bracket here. So let me do a little bit of simplification now here, where I'm going to square my numerator, okay, and square the denominator. And don't forget, when I multiply fractions, I multiply straight across. So this is now going to be 1 times 2, which is 2, and then you have that x plus 1 squared here. So you're going to distribute now. This term, this x plus 1 squared, gets distributed, meaning multiplied to the sum here. So we get 2 over, if I distribute that, I get an x plus 1 squared plus an x minus 1 squared. Because I have this cancel in the denominator, there's a, don't forget here, there's a cancellation here with these two terms, but we're distributing here first. Multiplying to this and this. And at this point, you can expand both of these. I don't want to do that. You can expand both of these. Y prime will be 2 over x squared plus 2x plus 1 plus x squared minus 2x plus 1. So what cancels now is these two x's. So y prime becomes 2 over 2x squared plus 2. And you can factor out the 2. So I have 2 over 2 times x squared plus 1, where the 2's cancel. And then y prime becomes 1 over x squared plus 1. So as you guys can see, there's a little bit of algebra here that you're going to have to do. And anyway, I don't know, let's do maybe one more here. I don't know, this is number what, 25? Yeah, we'll end with a nice 25. So y equals inverse tangent of natural log x. Okay. Y prime 1 over 1 plus. And I guess I did do this one. This looks like some deja vu. Should I check? Oh, I did. No, that wasn't it. Oh, inverse tangent of natural log x squared. Very similar. Okay. Well, it was similar. Okay, we didn't do the exact one, so let's finish that. So we differentiate by that natural log function. So that's 1 over x. Very similar. Y prime 1 over 1 plus natural log squared x times 1 over x. Y prime 1 over 1 plus natural log squared x, and then don't forget times that x. That's fine. Well, this is how we go through some of these questions here, which looks like it's pretty good. So I did want to give you some more of these kind of issues, and hopefully you guys can review some of these things And thank you for being here with me this morning. So we're going to put this up as soon as possible. Take care. Have a great day.